So, higher straight line, the first thing we're going to look at is the distance between 2 points. But instead of using our Nat5 strategy, which would have been to plot the 2 points, form ourselves a right angled triangle, and use Pythagoras' theorem to work out what the distance between those 2 points was, we're going to apply something called the distance formula. And the distance between 2 points, x1, y1 and x2, y2, is given by d, the distance, equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So basically we're finding the difference in the x coordinates and we're finding the difference in the y coordinates, and we're using Pythagoras but in something called the distance formula. So let's have a look at an example. So we want to find the distance between the points -3, 4 and 5, -1, and we don't want to have to plot those coordinates. We want to be able to apply the formula. So first of all, we're going to write down the formula. So d equals square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, if we look at the first coordinate as our x1, y1, and our second coordinate as our x2, y2, we can substitute those values into our distance formula. So x2 is 5, and we're taking away x1, which is -3, and we're going to square that, and we've got y2, and y2 is -1, and we're going to take away y1, which is 4, and we're going to square that. Now remember our rules of integers. If we're doing 5 take away -3, we're going to be doing 5 plus 3, so that's going to give us 8 squared. And -1 take away 4 is -5. And then we're going to square those, so 8 squared is 64. -5 squared gives us a positive 25. And so our final answer is root 89 units as an exact value. We can double check to see if we can simplify that, but there are no factors that are perfect squares of 89, so therefore our final answer is root 89 units.